Hello students, today I am going to teach you geometric progressions lesson, that is 16th lesson in your textbook. In grade 10 you have learnt about arithmetic progressions. First I am going to compare these two, arithmetic progression and geometric progression. Look at this number sequence. There is a common difference between two adjacent terms. Here difference is 4 and the difference is 4, again difference is 4. How you can obtain the common difference? Subtract previous term from a certain term. Now look at this number sequence. Difference is 3. Here difference is 6. Here difference is 12. The difference between two adjacent terms is not same. But you can observe here 3 multiplied by 2 6, 6 multiplied by 2 12, 12 multiplied by 2 24. We can say there is a common ratio between two adjacent terms. Here common ratio is 2. Here common difference is 4 between two adjacent terms. We can obtain common difference by subtracting first term from the second term. Second term is 7, first term is 3. Common difference is 4. We use the symbol D for common difference. You can subtract any two adjacent terms to obtain common difference. To find the common ratio of a geometric progression, we can divide second term by first term. Or you can divide any two adjacent terms. 12 divided by 6 also 2. 24 divided by 12 also 2. Here second term is 6. First term is 3. 6 divided by 3 is 2. We use simple R to represent common ratio. R equals 2. Now nth term of a arithmetic progression. It is Tn equal a plus n minus 1 times d. Here Tn is nth term, a is first term, n is number of terms, d is common difference. I name these terms here. Now I am going to explain about geometric progressions nth term. It is Tn equal a times r to the power n minus 1. Here Tn is nth term, a is first term, r is common ratio, n is number of terms. These are the meaning of these terms. Sum of n terms. What is the formula we use in arithmetic progression? There are two formulas. First one is Sn equal n divided by 2, 2a plus n minus 1 times d. Here Sn is sum of n terms. N is number of terms, a is first term, n is number of terms and d is common difference. You can use other formula to find the sum. It is Sn equal n divided by 2 and a plus l. Here a is first term, l is last term of the number sequence. To find the sum of n terms of a geometric progression, again we can use two formulas. First one is Sn equal a times r to the power n minus 1 divided by r minus 1. Second formula is Sn equal a times 1 minus r to the power n divided by 1 minus r. Here first formula, when you multiply by minus 1, you can obtain the second formula. When you multiply each and every term by minus 1, the sign of these terms change. You can use both formulas when you are finding sum of terms of geometric progression. Now look at again what we have learned so far. In an arithmetic progression, there is a common difference between two adjacent terms. In a geometric progression, there is a common ratio between two adjacent terms. This is the formula we use to find nth term of an arithmetic progression. This is the formula we can use to find nth term of a geometric progression. And there are two formulas we can use to find the sum of n terms of arithmetic progression. And again, two formulas we can use to find sum of n terms of geometric progression. Let's start to solve problems using these formulas. Let's start first example. Find the fifth term of 4, 12, 36 number sequence. In this number sequence, first term is 4. A equals 4. Then find the common ratio. Common ratio you can find by dividing second term by first term. 12 divided by 4, it is 3. 36 divided by 12, you can obtain common ratio. 36 divided by 12 also 3. Now you can use the formula. It is Tn equal A times R to the power n minus 1. Tn. A is 4. Substitute 4 here. There is a multiplication between A and R. So put multiplication symbol. R is 3. N. Number of terms. Question asks to find the fifth term. So substitute 5 for n. 5 minus 1. 4 times 3 to the power 5 minus 1 equal 4. 4 multiplied by 3 to the power 4 is 81. 4 multiplied by 81. It is 324. If you write fifth term in this number sequence, it is 324. Let's start second example. Find seventh term. First write first term. It is 5. Common ratio. Second term divided by first term. Minus 10 divided by 5. It is minus 2. In this question, common ratio is a negative term. Now write the formula we use to find nth term. It is Tn equal AR n to the power n minus 1. A is 5 multiplied by R is minus 2. Put a bracket. When you are writing negative numbers, put brackets. N. Find seventh term. So n is 7. 7 minus 1. 5 times minus 2 to the power 6. 5 times minus 2 to the power 6. It is plus 64. 5 multiplied by 64, answer is 320. In this number sequence, seventh term is 320. Now I am going to explain additional information about power of negative integer. In the previous question, we have to obtain minus 2 to the power 6. Now consider these values. All are negative integers. You have to take the powers of negative integer. First one minus 2 to the power 1. It is minus 2. Second one minus 2 to the power 2. If you expand it, it is minus 2 multiplied by minus 2. The value is plus 4. Minus 2 to the power 3. It is minus 8. Minus 2 to the power 4. It is plus 16. If this index is odd number, 1 and 3, odd numbers, answer is negative 1. If this index is even number, answer is positive. If index is odd, answer is negative. If index is even, answer is positive. Now look at these examples. Minus 3 to the power 1, it is minus 3. Minus 3 to the power 2, it is plus 9. 3 multiplied by 3, 9. 3 to the power 3, it is minus 27. Minus 3 to the power 4, it is plus 81. Let's start third example. First term is 0.05. Common ratio. You can divide second term by first term. 0.5 divided by 0.05. First convert these into whole numbers. Multiply both by 100. 50 divided by 5. It is 10. Here common ratio is 10. When you multiply first term by 10, it is 0.5. 0.5 multiplied by 10, it is 5. Now you can use the formula to find the sixth term. Tn equal a times r to the power n minus 1. First term is 0.05. Common ratio is 10. Number of terms, question asks about sixth term. 6 minus 1. 0.05 multiplied by 10 to the power 5. 10 to the power 5 means 1 and 5 zeros. Multiply this one by 100,000. There are 5 zeros, so you have to move this decimal point 5 places right hand side. Answer is 5,000. Sixth term of this progression is 5,000. Let's start fourth example. First term is 1. Common ratio. Half divided by 1. Half divided by 1. When you divide any term by 1, answer is the same one. Answer is half here. Now apply the formula. Tn equal a times r to the power n minus 1. First term is 1. Common ratio is half. Question asked to find fifth term. N is 5. 5 minus 1. 1 multiplied by half to the power 4. 1 multiplied by half, it is half. Now you can expand these brackets, remove brackets. 1 to the power 4 is 1. 2 to the power 4 is 16. Answer is 1 over 16. Now look at fifth question. The common ratio of a geometric progression is 3. Fifth term is 108. Find the first term. Common ratio is 3. R equal 3. And fifth term, T5 equal 108. You have to find first term. Now substitute these values for the formula. Tn equal a times r to the power n minus 1. Fifth term is 108. Substitute 108 for Tn. You have to find first term. Common ratio is 3. Fifth term means substitute 5 for n. 5 minus 1. 108 a times 3 to the power 4. 3 to the power 4 is 81. Now to find the value of a, divide both sides by 81. A equals 108 divided by 81. You can cancel both numerator and denominator by 27. There are 3 27s for 81 and 4 27s for 108. Simplest answer is a equals 4 over 3. In this number sequence, first term is 4 over 3. Let's start sixth example. First term of the progression is 3 over 2. A equals 3 over 2. Seventh term, T7 equal 96. Find the common ratio. Now substitute these values for the formula. Formula is Tn equal a times r to the power n minus 1. Nth term, it is 96. First term, 3 divided by 2. You have to find common ratio. Seventh term, so n is 7. 7 minus 1. First, cross multiply by 2 and 3. 96 multiplied by 2 and divide by 3 equals r to the power 7 minus 1. It is 6. Now you can simplify these two by 3, 1 and 32. 32 multiplied by 2, 64 equal r to the power 6. To find the value of r, write this as a power with index 6. You can write 64 as 2 to the power 6, r to the power 6. Now both sides same index. Then you can write r equals 2 when you cancel this index, or you can take 6th root of both sides. Take the 6th root of both sides. it cancels 6 in the index, r equal 2. Here you have to take plus or minus 2. I am going to explain this one, why we take plus and minus both here. Now I am going to teach you an additional information to find the value of r. Here r to the power 2 equal 4. To find the value of r, you have to take the square root of both sides. 4, you can write it as 2 to the power 2. 4 equals 2 to the power 2. Take the square root of both sides. R equal squared and square root cancel 2. But you have to write here plus or minus. Plus 2 multiplied by plus 2. It is plus 4. Minus 2 multiplied by minus 2. It is also plus 4. When you are taking square root of plus 4, answer should be plus or minus 2. Now look at second one. R to the power 3 equal 8. Now write 8 as a power with index 3. It is 2 to the power 3. I am going to multiply plus 2 by plus 2 by plus 2. It is plus 8. Minus 2 multiplied by minus 2 multiplied by minus 2. Minus multiplied by minus plus, plus multiplied by minus, minus. You have to take the cubic root of both sides. But when you multiply plus 2, you can obtain plus 8. But when you multiply minus 2, you cannot obtain plus 8. So in this one, you have to accept only plus 2. R equals plus 2. Next example, r to the power 4 equal, write this as a power with index 4. It is 2 to the power 4. 2 multiplied by 2 multiplied by 2, the answer is plus 16. But if you multiply minus 2's, minus multiplied by minus plus, again minus, again plus, answer is plus 16. If you take plus 2 or minus 2, both times it is plus 16. So what is the value of r? You have to take both plus or minus. Answer is r equal plus or minus 2. If this index is even, you have to take both answers, plus and minus. If this index is odd, you have to take only positive answer. Here index is odd number. You have to take only positive answer. Here index is even number. You have to take both positive and negative. Now look at these examples. R to the power 2 equal 9. You can write this as a power. It is 3 to the power 2. Now both sides same index. R is equal to plus or minus 3. Here index is even. So you have to write both. Next example. R to the power 3. You can write this as 3 to the power 3. But index is odd. So answer is only plus 3. Next example, r to the power 4. You can write this as 3 to the power 4. R equal, here even index. So write both answers, plus or minus 3. R equals plus or minus 3. R to the power 2. Write this as a power. 1 to the power 2 and 16 you can write 4 to the power 2. 1 over 4 to the power 2. Then r equals, here both side index is 2. It is even index. Then cancel index and write the value of r. It is plus or minus 1 over 4. Look at the last one. R to the power 3. Write this as a power. 1 to the power 3. 64 equal 4 to the power 3. 1 over 4 to the power 3. Now both sides same index. It is odd. So you have to select only positive value. R equals plus 1 over 4. Let's start 7th example. The common ratio of a geometric progression is 2. R equal 2. First term is 2. A equal 2. Which term is 64? Tn equals 64. Which term means here you have to find simple n. Now substitute these values to the formula. Tn equal a r to the power n minus 1. Tn is 64. First term is 2. Common ratio also 2 to the power n minus 1. First remove this 2. Divide both sides by 2. Divide both sides by 2. 32 equal, these 2 cancel, 2 to the power n minus 1. Now right side, this is a power. Left side as a power with base 2. 32 equal 2 to the power 5. Now you can see both sides same base. Base is 2. Now you can equal their indices. 5 equal n minus 1. Then take minus 1 left side, it is plus 1. Then answer is 6. N equals 6. Therefore, question asks which term is equal to 64. Sixth term is 64. Now look at 8th question. If the third term of a geometric progression is 12 and fifth term is 48, find the first term and common ratio. Write the first 5 terms of the progression. Use formula Tn equal ar to the power n minus 1. I take this left side, ar to the power n minus 1 equal, third term is 12. Substitute 3 for n. ar to the power 3 minus 1 equal 12. ar to the power 2 equal 12. Take this one as first equation. And the second one, fifth term is 48. Again ar to the power n minus 1 equal 48. Fifth term, substitute 5 for n. Then ar to the power 4 equal 48. Second equation. Now there are 2 equations. We can call these as simultaneous equations. 2 equations and 2 unknown terms. By solving these 2 pair of simultaneous equations, you have to find the value of a and r. To solve these 2 equations, divide these 2 equations. I am going to divide second equation by first one. Divide second equation by first one. First divide left side. ar to the power 4. Left side of second equation. Then write the left side of first equation. ar to the power 2. Now divide right sides. 48 divided by 12. You can cancel a. Then you can cancel 12 and 48. It is 4. Left side r to the power 4 divided by r to the power 2. When you have to divide powers with same base, you have to subtract their indices. R to the power 4 minus 2. Again, I am explaining this one. When you have to divide powers with same base, subtract their indices. R to the power 2 equals 4. Now you can write this as a power 2 to the power 2. Now both sides same index. So you can equal r equal 2. But remember this one, here index is even number. So you have to take both positive and negative as the answer. R equal plus or minus 2. We obtain 2 values for r equal plus 2 and minus 2. Now I am going to substitute r equal plus 2 in first equation. Substitute in first equation. ar to the power 2 equal 12. r to the power 2 plus 2 to the power 2. Plus 2 to the power 2, it is 4. A multiplied by 4 equal 12. Divide both sides by 4. A equals 3. When r equal minus 2. Again I am going to substitute it in equation 1. Equation 1 is ar to the power 2 equal 12. R to the power 2 is, r is minus 2. Minus 2 to the power 2. Minus 2 to the power 2 is plus 4. Then divide both sides by 4. A equals 3. There are two different values for r, but the value of a is same here. Now look at the question again. Find the first term and common ratio. Write the first 5 terms of the progression. Now you have to write first 5 terms of the number sequence. When a equal 3, when r equal plus 2, write the first 5 terms. First term is 3, then multiply it by 2, 6, multiply again by 2, 12, multiply by 2, 24, multiply by 2, 48. These are the first 5 terms for a equal 3 and r equal plus 2. If a equal 3 and r equal minus 2, first term 3, 3 multiplied by minus 2, it is minus 6. Minus 6 multiplied by minus 2, it is plus 12. Plus 12 multiplied by minus 2, it is minus 24. And minus 24 multiplied by minus 2, it is plus 48. There are two different number sequences for this question. Let's start 9th example. If the third term of a geometric progression is 40 and sixth term is 625, find the first term and common ratio. Write the first 5 terms of the progression. First use the formula. Tn equal ar to the power n minus 1. Third term ar to the power n minus 1 equal 40. Now substitute 3 for n. ar to the power 3 minus 1 equal 40. ar to the power 2 equal 40. This is the first equation. And sixth term is 625. Now substitute 6 for n. 6 minus 1. It is ar to the power 5 equals 625. This is the second equation. Now you obtain pair of simultaneous equations. I am going to divide second equation by first one. First divide left sides. ar to the power 5 divided by ar to the power 2. Right sides 625 divided by 40. Now left side you can cancel a. r to the power 5 divided by r to the power 2. You have to subtract indices. 5 minus 2, it is 3. You can simplify right hand side by 5. Divide both by 5. It is 125. 40 divided by 5 is 8. Now write right hand side as a power with index 3. 125 you can write as 5 to the power 3. 8 you can write as 2 to the power 3. Now left side and right side all indices are 3. r equal 5 divided by 2. Here index is odd number, so you have to take only positive answer. Now you have to find the value of a. Substitute r equal 5 over 2 in equation 1. Equation 1 is ar to the power 2 equal 40. A multiplied by r to the power 2. r is 5 over 2 to the power 2. 5 to the power 2, 25. 2 to the power 2, 4. Now cross multiply by 4 and 25. You can cancel these two by 5. 5 and 8. Answer is a equals 4 multiplied by 8, 32 divided by 5. A equal 32 divided by 5. Question says to write first 5 terms. First term is 32 over 5. Then common ratio is 5 over 2. Multiply this one by 5 over 2. 32 divided by 5 multiplied by 5 over 2. Cancel. 16. Second term is 16. Then multiply second term by common ratio. 5 over 2. 2 and 16, 8. 8 multiplied by 5, 40. Third term is 40. Then multiply 40 by common ratio. Cancel. 20 multiplied by 5, 100. Fourth term is 100. Then multiply 100 by 5 over 2. 100 multiplied by 5 over 2. 50 multiplied by 5, 250. These are the first 5 terms of the above number sequence. That is all for today. Goodbye everyone.